So, what's the universe made of? I mean, really, it's a huge question, right? Well, today we're going to tackle it. We're diving into matter, the literal stuff that makes up, well, everything. You, me, this planet, the stars, all of it.
And to really wrap our heads around this, we've got to start big. I mean, really big. Like exploding stars big. Yeah, you heard me right. The very stuff that makes up our world, our bodies, everything you can touch and see, it was all cooked up billions of years ago inside giant stars. And when those stars exploded, they scattered all that material across the universe. So it's not just a poetic thing to say, you are literally made of stardust.
So, what exactly is this cosmic stuff? And how in the world does it go from being scattered dust to building entire stars, planets, and yeah, even people like us? Let's get into it.
All right, first things first. We need to get on the same page. What are we actually talking about when we use the word matter?
Okay, here's the simplest way to put it. Matter is just stuff, the physical stuff that things are made of. You know, from the sun and the farthest stars, all the way down to the air you're breathing and the floor beneath your feet, it's all matter. Pretty much the whole universe, as far as we can tell, is built from just two basic ingredients, matter and energy.
But here's where it gets interesting. This universal stuff isn't all the same, is it? Nope. It shows up in a few different forms, or states, as scientists call them, that you see every single day.
You know these already for sure, solids, liquids, and gases. But have you ever stopped to think what actually makes a block of ice different from a puddle of water or a cloud of steam? They're all just water, right? It all comes down to how the tiny little particles that make them up are, well, how they're behaving.
Okay, so in a solid, like that block of ice, the particles are packed together super tight. They're all in a neat, orderly structure. They're vibrating a little, they've got energy, but they can't actually go anywhere. And that's what gives a solid its fixed shape and makes it feel, well, solid. Now, what about a liquid? Well, here the particles are still pretty close, but they're not locked in place anymore. They can slide and move past each other. And that's exactly why you can pour water and why it takes the shape of whatever glass you put it in.
And then you've got gases, like steam. This is where the particles have totally broken free. They're super far apart and they're just zipping around like crazy, bouncing off the walls. That's why a gas will always expand to fill up any container you put it in, no matter how big.
Okay, so matter is made of particles. We get that. But what are these particles? Right, it's time to zoom in. And I mean way in. We're about to meet the fundamental building block of pretty much everything. And look, when I say we're zooming in, I'm not kidding. Try to picture this. You see the dot over a lowercase I? How many of these particles do you think could fit in there? 1,000? 1,000,000? Nope. You could fit about 1,000,000,000,000 of them inside that tiny dot. That's a 1 with 12 zeros after it. It's just mind-bogglingly small.
These tiny, tiny particles are called atoms. And for a really long time, everyone, all the scientists, they thought that was it, the end of the line. They figured the atom was the smallest thing possible, that you just couldn't slice it any smaller. But it turns out there was a surprise waiting for them. Yeah, because you can go smaller. There's a whole world hiding inside the atom. So let's dive in and see what's there.
You know, our idea of what an atom looks like has changed a lot. At first, scientists had this funny idea called the plum pudding model. Just imagine a blob of pudding with little bits like plums scattered around inside. Then they got a little closer with the planetary model, picturing a center with other things orbiting it, kind of like planets going around the sun.
The real picture, as we know it today, is a little more complex, but also kind of cooler. Right in the middle of every single atom, there's this super dense core called the nucleus. And then, whizzing around that nucleus are these even tinier particles called electrons. But they're not just flying around randomly. They stick to specific paths, or shells, almost like they're in lanes on a cosmic racetrack. So when you break it down, you've got three main players on this team. In the center, in the nucleus, you have protons, which have a positive charge. You also have neutrons, which are, you guessed it, neutral, no charge at all. Then, flying around in those shells are the electrons, and they have a negative charge. And this is the really crucial part. That opposites attract thing between the positive protons and the negative electrons is what holds the entire atom together. It's the cosmic glue that makes all the stable stuff in the universe, well, stable. All right, we've gone super deep, right? Right down into the guts of the atom. Now, let's zoom back out a little bit and see what happens when these atoms start, well, teaming up. See, atoms are pretty social. They don't usually like to be alone. They almost always bond together with other atoms. And when two or more of them link up, we call that a molecule. Now, if those atoms are different from each other, they form a special kind of molecule we call a compound. Let's use a super common example to make this clear. Take sodium. By itself, it's this soft silvery metal that can actually explode if it touches water. Then you've got chlorine. On its own, it's a nasty, poisonous green gas. So yeah, two very different things, and you definitely wouldn't want to eat either of them. But when these two get together, something amazing happens. The sodium atom basically hands over one of its electrons to the chlorine atom. This little exchange creates this powerful attraction, a bond, that snaps them together. And just like that, they form a totally new substance, sodium chloride. You probably know it better as plain old table salt. Crazy, right?
And molecules aren't always just two little atoms holding hands. They can be absolutely gigantic. I mean, get ready for this one. A single molecule of DNA, the stuff inside your cells that makes you you, if you could unravel it and stretch it out, it could be as long as your finger. That's one molecule made of millions upon millions of atoms all linked together.
So let's just take a step back and look at the journey we've been on. We started with literal stardust from ancient exploded stars. We saw how that stardust arranges itself into solids, liquids, and gases. Then we dove all the way down deep inside the tiny atom to meet its core particles. And then we saw how those atoms link up to build everything from a simple grain of salt to the unbelievably complex DNA that makes you who you are. So I guess the thought I want to leave you with is just, isn't that amazing? This whole huge, complicated universe, all built from just a few types of tiny, simple particles working together.